Good morning, everyone. So, I, Dr. Manali Madhav Kumthekar, on behalf of GK Guzar Memorial Trusts, Dr. Ashok Guzar Institute, Technical Institutes, Dr. Davlatra Wahir College of Engineering, Karad, welcome to the Day 2, Session 3 of ATAL FDP on Industry Academia's Synergy in Disaster Management and Resilient Infrastructure for Advancing Sustainable Development. Dear participants, as this is our very first experience in organizing an ATAL FDP, we seek your kind support and understanding. In case of any unforeseen issues, we assure that we are making every possible effort so that we can manage and resolve them promptly. This FDP is very close to our hearts as it is a dream envisioned by our mentor, Dr. M.B. Kumthekar sir. Your support and understanding will truly help us in taking this journey forward and honoring his vision. Thank you for being a part of this journey. Now, today, it gives me a great pleasure to introduce today's distinguished speaker, Dr. Sangram Nirmale, sir. Dr. Nirmale is currently an assistant professor in the Department of Civil Engineering at the Indian Institute of Technology, Bombay. He is also an associate faculty at the IIT Bombay FedEx Center for Advanced Logistics and Focused Analytics, where he contributes to interdisciplinary research in transportation systems, logistics, and data driven analytics. Dr. Nirmale has completed his PhD in transportation engineering from the Indian Institute of Science, Bengaluru. His doctoral research focused on advanced driver behavior modeling in heterogeneous and disorderly traffic conditions, with an emphasis on multi vehicle anticipation and behavior realism. He holds an MTech in urban planning from VNIT Nagpur and bachelor's degree in civil engineering from Government College of Engineering, Karad. Before joining IIT Bombay, Dr. Nirmale worked as a research scientist at IISc Bengaluru, where he was actively involved in developing activity-based travel demand models and traffic simulation frameworks for Indian cities in collaboration with government and industry stakeholders. Dr. Nirmale has an outstanding profile with multiple publications in leading international journals such as Transportation Research Part A, Part B, and Part C, Transportation Policy, and Transportation Letters. He has presented his work at several prestigious national and international forums, including the Transportation Research Board annual meeting in Washington, D.C. In recognition of his research contributions, Dr. Nirmale has received several prestigious honors, including the Prime Minister Earlier Career Research Grant awarded by the Government of India and the Young Faculty Award from IIT Bombay. He has also received multiple Best Papers and Best Presentation awards at national and international conferences. He is currently leading and contributing to several sponsored research projects funded by agencies such as the Anusandhan National Research Foundation, Mumbai Rail Vikas Corporation Limited, and the IIT Bombay FedEx Center for Advanced Logistics and Focused Analytics, focusing on behavioral travel modeling, transit forecasting, accessibility analysis, and sustainable urban transportation systems. Along with his research, Dr. Nirmale is deeply committed to teaching, mentoring, and academic service and currently supervises PhD and MTech students in the area of transportation engineering. He also served as a reviewer for several leading international journals. Today, Dr. Nirmale will be sharing his insights on transportation engineering for effective disaster management. Please join me in warmly welcoming Dr. Sangram Nirmale for today's session. Over to you, sir.
Yeah, thank you. Thank you so much, Dr. Manali and other participants. So, am I audible? Hello?
Yes, sir, you are audible.
Okay. Yeah. So, thank you so much, Dr. Manali and other colleagues. Uh, So we'll start soon. Let me start. I will share my screen. Can anybody confirm whether my screen is visible or not? Okay. Yeah. Is my presentation visible?
Yes, sir, we can see.
Yes, sir.
Okay. Yeah. So, good morning, all. So, before we start our presentation, I would like to remember my sir, Professor Dr. Madhav Kumtekar. So, I was his student from 2010 to 14. I personally interacted with him, and so we have very close relationship. So, it is like disheartening that he's not here, but his memory will be with us. So I just want to give the tribute to my beloved sir, Kumtekar sir. So I think you all know Professor Kumtekar and his contribution to academics, and even not only academics, he also changed many people's life through his teaching, through his mentorship. So I just want to remember him. So I hope everyone knows that he will be there forever with us. Okay. So with that, uh, we will start today's presentation. So today I will be talking about the transportation engineering for effective disaster management. And you need to know that when I'm speaking in this presentation, I will be covering most of the topics, but the time is very short, and the methods or tool used to do this disaster management that at least take like semester or 2 semester courses to understand fully. But what I will try to do is I will try to give the overview of all these tools used in effective disaster management, particularly with focusing on the transportation engineering. And once you know all these tools, then let's say if you want to, I think someone raised hand. Yeah, please go ahead. Rajendra raised hand. Do you have any doubt? Okay. Yeah. So if you have any doubts, so you can just unmute yourself and you can ask me. So I'm not able to see all participants. Okay. So to briefly discuss, if we want to describe the disaster management, so it is basically a systematic process of planning, coordinating, and implementing the measures. So this is the overall definition of disaster management. And basically, if we try to see what is the objective of disaster management, it is simple. So basically, it is to reduce the adverse impact of disaster. because majorly it affects the people who are living it at the particular location. So our main aim will be to reduce this adverse effect, then protect human life, which is very important, then minimize the economic losses and ensure that the rapid recovery of affected system and community. So when I'm saying system, so it's not only a system of transportation system, it involves all the infrastructure, which will be important for people who are residing in that particular location. And when we talk about the disaster, the first thing which get affected is the transportation network. Okay, so that's why we need to first start with the reviving the transportation network, because if you want to save people or save life, the important infrastructure which play a critical role when traveling from one location to another or making people move from one location to the another location, the transportation network is very important. So that's why in this today's lecture we will discuss how we can actually perform some measures or do some activities in order to save the transportation infrastructure, or how we can actually strengthen the transportation network. And you all know, if there's an insufficient transportation system, that will delay all overall the procedure of evacuation, which is important in the case of the disaster in order to decrease the fatalities. Okay. And as I said, transportation engineering plays critical role in risk reduction, because that's what we want in disaster management. Then also emergency response and post disaster recovery. These are the three important points when we discuss about the disaster management in terms of transportation engineering, and how we can do. So if we want to do the reduce the risk, then improve the emergency response and have the post disaster recovery, we need some data. So when I speak about the data, this data is particularly utilized when we are building the models. And in the today's lectures, we'll also see what are the different types of models are present, and how these models will be helpful to do the efficient and effective disaster management. So that's why we need the data driven solution, particularly when we discuss about the transportation system. And you will also see, if you move towards the different modeling framework, the data is must. Without the data, you cannot even build the model or you cannot calibrate those model. So we'll also discuss what type of data will be required to do this type of modeling framework. So if we see the types of disaster, there are two types of disaster. One is the natural and another one is the man-made. In natural disaster, it includes earthquake, flood, cyclone, landslide. And in terms of man-made, there are industrial accident, terrorist attacks, or large-scale fire. So these are the two types of disaster. But the effect of disaster when happens, our main goal will be first to reduce the fatality and make the risk as possible as to reduce it. Okay. So even if it is a natural or man-made, the disaster management is important, irrespective its types. And when we see this disaster, what is required here, we need to first see what are the impacts it make on the transportation. So the first and very most important is it reduce the network capacity. So what do you mean by network reduction capacity? Let's say you have a road and it can carry 2000 vehicles per hour. Okay. So if it has a two-lane road and one road gets affected because of the disaster, then what will happen? The capacity of this road get reduced. So that's why we say that the capacity reduction. So even if one or two link for the whole road get affected, then what will happen? It will reduce the capacity and it will create the bottlenecks. So then you will see that there will be queue length, here, because earlier the capacity was 2000 vehicle per hour, but now it will get reduced, and maybe let's say because of the one lane is not present, it might be 1000 vehicles per hour. So that's what happened when it affects the transportation network. The second thing you will see, so the first example you will see from here, that road gets affected and the capacity dropped because there is no connection. The second thing will be it might damage your bridges or tunnel. So once it damage your bridges, then also it will affect the network capacity and you cannot move the people. Okay. So this is the very important thing, and it plays an important role when you have a disaster and your network capacity dropped or becomes zero. Then you need to find some alternative ways to travel. And if it is not there, then you will be at steady state situation where you cannot even move people. So when you are doing the disaster management, you should know that there should be alternate ways or alternate routes should be present to move people from one location to another location. Then if this is happened, then you can also see that there will be the traffic chaos due to panic behavior of human drivers. So because the most of the vehicle is driven by the human, then they will lead to the panic behavior, and that also create the chaos. Then if road network is getting affected, is it sometimes also affect the communication and control failure. Let's say if you have a road network and you have a traffic signals, okay, so those traffic signal also plays an important role to control the traffic. If you don't have that road network, or if your road network get affected, then that also fails. So control also fails in disaster. Okay. So the transportation engineering contribute to the three critical phases. One phase is pre-disaster. Basically, before even disaster happens, we need to be really prepared. Okay, as I said, if there is only one connection through bridge, then we should have a alternate ways to reach that particular location. So that will come under the pre-disaster. During disaster, we need to respond to that disaster. That also will majorly focus on how we can manage your traffic and basically reduce the chaos at particular location. The last thing will comes to the recovery stage. So in the recovery stage, or it also called the post disaster. So if something's happened, something happened for the road infrastructure or bridges, then how you can actually recover that as early as possible. So that comes under the post disaster phase. And when I talk about the models, and you will understand why I am majorly focusing on the models, because until unless you have the models, you cannot come to the conclusion what measures needs to be taken. Okay, so that's why I'm saying the models are important, and this model takes the data, and you cannot build the same model for all three phases. Okay, so that's why for pre-disaster phase you need to have different models. During disaster you need to have different models, and most probably it should be real-time models. And in the post-disaster phase you need another models. But when you have a different models, you need to have the data. Okay. And once you have the data, then you can build those model, you can calibrate those model and take the policy decisions. Okay. So in that case, the models plays an important role. So in today's lecture, we'll also briefly discuss those models, or what are the different models required and data required. And if you are really interested, you can also go ahead. Once I give you brief overview, you can explore those model, and those models are not like a physical model. Those are mathematical models. Those mathematical models are used in practice. Basically, here we also use some transportation related models. For example, they are like four-stage travel demand models, activity-based travel demand models. Those are used in planning, majorly transportation planning, and we required some different data. So you can say that mostly this stage is very important or phase, the pre-disaster. If you are very good at pre-disaster or preparedness, then the impact of other two phases is less on the infrastructure. And we will see that how these models can be used to reduce the impact and make us more prepared. Okay. So when we discuss about the pre-disaster phase, there are some challenges and we also discuss some engineering solution. So for example, if you see, the first challenge will be we will have uncertain and rare disaster events. Correct? So when I say uncertain, you cannot predict when earthquake will happen or when flood will come. You have some models where you can predict, but you cannot predict exact time or location. So that is one of the challenge. Then it's also become very difficult which one become the critical transportation link. Okay, that is also not possible. It is possible, but it is very difficult. Okay, then when you are actually preparing the evacuation route planning, you need to know the location. Until unless you know the location where it could possibly happen, you cannot do the route planning. The very important point is this one. You don't know how human will behave when the disaster happened, because there will not be one or two people. There will be thousands of people who are getting affected by a disaster, and it becomes very difficult to predict their behavior. When I say predict their behavior, I am saying what type of, let's say, the disaster happens at location this A location, and the safe location is B. So they need to travel from A location to B location. A disaster is happening here. Okay. So when I say the human behavior, the first thing will be, let's say, if they want to go from location A to B, what type of mode they will choose to go from A to B. Then what type of route, because there will be multiple route, what type of route they will choose, at what time they will leave. When they are leaving, they will travel with the together or they will just alone. So all this affect for the route planning as well, because what are the choices they are making that will put the traffic on the road. Okay, and we have the model, by the way, we have those models to predict which type of mode they will use, which type of link or which type of route they will take. That is there, but that is also unpredictable. So to predict their behavior, we need the data. Okay. Then we also don't know what will happen with the particular link or the road. So there will be vulnerability for particular infrastructure. Let's say there is a bridge. Okay. If at this location, A location, the disaster is happening, whether it will affect this bridge or not, that you are not sure. Or sometimes, let's say, because there is some disaster happening here, many people are taking this route. Because of that, whether this bridge will be sustainable or not, that also you don't know. And we will see how we can actually test this, whether it will happen or it will create some problem or not. That also I will talk about. But I will give you overview and you can explore it later. But there are some mathematical models where you can utilize those mathematical models and you can predict what will happen. Okay. And as these events are rare, you don't have the sufficient data to build or calibrate those models. Okay. So insufficient data is also one of the issue with these models. Then equity and accessibility issue. So basically, when people are traveling from here and there, first we need to see whether all these modes, all these routes are accessible to all people, or it is only accessible to certain people. So this equity and accessibility also becomes an issue when we see the pre-disaster phase. Okay. And what are the engineering solutions? So basically we can do the scenario-based modeling that I will talk later on, where you can have a different models, and those models can be used to see what if scenarios. If you have different scenarios, then you can predict what will happen in the particular link or particular road. Then you can also do the redundancy analysis for particular network or mostly the evacuation network. You can do the traffic assignment model for evacuation demand. So I'm not sure how many of you are from transportation background, but let's say if you're not from transportation background, I will quickly say there's a very famous model that is called four-stage travel demand model. Okay. So there are four stages. The first one is the trip generation. Second one is the trip assignment, sorry, trip distribution. Third one is the mode choice. And fourth one is the trip assignment, or we also call it as a traffic assignment. Okay. So if you are from transportation background, you might be well versed of this four-stage travel demand model. So the last step, what we do is we assign the traffic on the roads. When we assign the traffic, we need the demand, and this demand will come from these first three stages. So that's why it is also called the travel demand model. Sorry, travel demand model. In that case, this traffic assignment becomes very useful. Okay. And as I said, once we have these models, we can do the different scenario-based modeling, and we can do the scenario testing. Once we have this model, we can also see whether particular network, if I have this network, which network is vulnerable. So that also we can check based on those models. And then we can integrate the emergency transportation planning framework. So for example, if I want to move ambulance from this particular road network, how can I do that? So that comes under the integrated emergency transportation planning framework. So that can also be done. And once we know all this data, all this model, then we can actually solve the issue of this equity and accessibility. So we can propose some accessibility based evacuation performance measure. So this will be also there. Okay. Mhm. So in the emergency response, what we need to do is, or what we see, the challenges will be the sudden demand surge, because earlier, let's say people was not traveling, but when the disaster happens, suddenly the demand increases. So again, let's say if this is the city is divided, and something happened here. Okay, then what will happen? Usually, you will see that very few people are traveling from this particular location to other locations. But now, because of this demand, because of this disaster, many people start traveling from this, and that will put the so much traffic on this road network. So that's why it creates the sudden demand surge. Then what will happen? Because they are traveling and maybe the capacity get reduced, as we already discussed, the network capacity might get reduced. Then driver becomes panic, and they might also violate some rules because they want to suddenly move away from that location. Okay? And it will also lead some partial network failure or sometimes full network failure as well. Okay. And most of the time, what happens, we get limited information because there is a connection lost and everything. Then you will not get so much information, and that information affects your behavior, what will happen, and when you are moving from here to there. So what do we do? In this situation, the engineering solutions are we do the dynamic traffic management. Okay, again, there are some models, there are some frameworks which can do the dynamic traffic management. So what we'll do, particularly when when the presence of the disaster, how the traffic will change. That will be done by the dynamic traffic management. Then we do contra flow lane operation. So we will change the operation of lane. Maybe we will allow some vehicles on that particular lane, or mostly what we'll do, let's say it is only one way or two-way lane, we will restrict some movement. So that is also possible. Then we'll provide the real-time route guidance. So with the recent technology, it is possible to provide some real-time route guidance. Maybe we'll put some boards here in a way that they can understand what is happening at different position, and will give some priority to the emergency vehicles. So for example, ambulance and all, we can give some priority. So these are the different engineering solutions available when we are dealing with the during disaster or emergency response phase. Okay. Then the last one is the post disaster or recovery or resilience. Okay. Again, the challenges will be rapid damage assessment. We need to first assess how much damage has already happened because of the disaster. Then we need to see, or we need to provide some temporary traffic management, because of this disaster, you will see that there will be so much issues which created which was created because of the disaster, and we need to address those issues by doing some temporary traffic management, because there could be some rule violation happened. People are moving on the road without any rules following. So that will be covered by the temporary traffic management. Then we need to see which infrastructure needs priority to be handled. So that also we can do modeling, and we'll see, okay, which is the critical infrastructure needs restore, and that prioritization we can do, and how we can do the long-term resilience planning. So in order to, let's say in future, such type of events, what we can do, that can be also done in the post disaster. So the engineering question will be which links to restore first, for example, giving the priority, then how to minimize the economic loss, and how to design fail-safe network. We cannot do the fully fail-safe network, but we'll try to do that. Okay. Or at least reduce some losses. So that will come under the recovery and the resilience. Okay. So now, so as I said, there will be so many modeling framework we will be using in order to model all the events. And how we will do that? So there are some transportation engineering tools available to do all this modeling. So for example, there are some traffic flow theory. Okay, so if you are a student of transportation engineering, or even if you are a bachelor's in civil engineering, you might have taken the transportation engineering course, and you have studied the traffic flow theory. The simple traffic flow theory, or the basic what you have studied, is the free flow diagram. So speed, density, and flow you might have seen, and how you can utilize that to effectively design your network. So that comes under the traffic flow theory. Then there are some discrete choice model. This is if you are not from the transportation background, so this might you might be seeing this first time, the discrete choice models. So these discrete choice models are nothing but you have a discrete choices. For example, in terms of transportation, let's say you want to go from one location to another location, and you have a different types of modes available. For example, two-wheeler is there, car is there, bus is there, auto rickshaw is there. And for that particular trip going from origin O to destination D, what mode you will choose? That that modeling, it's nothing is done by discrete choice models, and same theory can be utilized to see what type of route choices people will do under the stress. And why under the stress? Because during the disaster, people will be so much in stress and they want to they are not in the situation where they will do some rational choices or something. So how you will actually make the route choice or model the route choice, that can be done using the discrete choice model. And again, so here I am only putting the theoretical part. I am not even showing you the mathematics behind it. So don't think that okay, it is only the theory part, because we have limited time. That's why I have not even included any single equation. But all these models or theory or tools, they have the solid mathematical foundation. I work in this discrete choice models, network optimization, even simulation models, even traffic flow theory. So if you are really interested, so what I would suggest, or let's say if you want to do some research on this area, I would suggest you to just take down the note of these names, and you will get ample number of research paper or research material, how these theories are actually used in practice, and you can also do the theory part. So my research work majorly focused on the discrete choice model. I developed many discrete choice models as well. So I would be happy to discuss that later on, or if you want, you can just go through my Google Scholar and you will see that what are the different discrete choice models are there. But for time constraint, I'm just telling the names. So don't think that it is just the uh, like theory I'm covering. There are solid mathematics behind it. Okay. Then the third one is the network optimization. So network optimization is used when we are doing the or finding the shortest path with the damaged link, because the whole network will not be available. Then how we'll do that? And once all the models are ready, then what we'll do, we'll also put those model into the simulation framework. And there are different types of simulation models are available. For example, Visum is there, Simo, MatSim, ActivitySim. So there are some free software tools are available, and some of them are a paid version. So for example, Vism is the paid version or the commercial version, and Sumo is freely available, or it is open source. So you can also explore, if you want to work on this framework, you can also explore those models. Okay, so what we'll do now, we will quickly go through each and every tool or theory which we discussed. Again, at I will just give you the overview, but you can also go back and read more about it, so that this will help you to get more understanding of these theories used during the disaster. And if you are doing some research, then you should go ahead and read all these theories. So that will be really helpful for you. Okay. So when I'm talking about the traffic flow theory, so so during disaster, what happens? The traffic does not behave normally, and that you already know. So basically, as I already discussed, there is a surge in demand, and this demand is increases within a fraction of time. So the capacity of the road often gets reduced. Correct. Because of the disaster condition, the capacity get reduced and the demand increases. So once this happens, you need to know the theories behind it, how we can actually model those and come up with some tool or decision to manage that traffic. Okay, in that situation, the traffic flow theories help a lot. So basically, traffic flow theory helps to quantify how that congestion propagate backwards as shock waves. Okay, so basically it will allow planners or transport planner to predict the gridlock location. So where gridlock means where the congestion is so much high and people can't move. Okay, so traffic flow theory will allow you to predict that one and come up with the solutions. So used word here shock wave, right? So in transportation, the shock wave is defined as it is a traffic phenomenon which describe the sudden significant change and propagation of traffic conditions. So basically, if you read about the transportation or transportation engineering, mostly we define the network into speed, flow, and density. Okay, these are the three variables are used. And this sudden and significant change, which is caused by the bottleneck. And why bottleneck happen? Let's say if you have this road, okay, and suddenly the capacity got reduced. So basically, this is two-lane road, and now it becomes one lane. Okay. So this is nothing but the bottleneck. Okay. So capacity suddenly reduced. So here the sudden change will happen, and initially few vehicles will go. Okay. If the capacity or the volume is less than what this one lane can carry. But if still increases, what will happen? So vehicle will get pile up here. Correct. And this can be done or can be analyzed using the shockwave analysis theory. Again, you can go back and read about, there is so many books are available where you can read about the shockwave theories. Okay. So bottleneck, and this bottleneck can be due to accident lane. And you might have seen this type of scenario when you travel on the road. So let's say if you are traveling on highway and some accident happens, you will suddenly see that the road, even though the capacity is great or three-lane capacity is there, because of the accident, suddenly you will start seeing the traffic congestion happens. So that can be described by using shockwave theories. Okay. And basically that will move forward or backward. Okay. Based on what is happened, whether it is accident, lane closure, or traffic signal. So that we are not covering here, but there are some tools or theories which can help you to analyze them. And this will help you to do the design part, design of the road network. Okay. So in that case, it is very useful to know how the traffic behave or traffic flow behave. So basically, the traffic flow theory analyzes the traffic dynamics under extreme demand and disrupted supply, okay, that we already see. And here the critical concepts are, first one is the capacity drop under the panic driven flow that we have seen. Then shockwave formulation because of evacuation and sudden drop in the capacity. And there are some bottlenecks, split for slip back near the shelter and exit. And that also we have already seen. So this traffic flow theory will be used to estimate the evacuation clearance time. So basically, if some event happens, so how much time it will take to clear. Okay. So that you as a transport planner or transport engineer, you can predict the time doing the traffic flow analysis theory. You can also identify the critical link and failure point in the network. And you can also design the contraflow and lane reversal strategy because you need to somehow increase the capacity. Then how you can increase the capacity, that also you can do, or which link you can open for to increase the capacity. That can be done using the traffic flow theory. So basically capacity drop is especially important during the evacuation where stop and go behavior reduces the effective roadway throughput. Correct. So that we have seen using the figure. And these insights, why these insights are important because that will support the pre-disaster evacuation planning and real-time traffic control. So if you don't do this analysis, then it is very difficult to do the pre-disaster evacuation planning. So you need to create some what if scenario in your modeling framework or simulation framework to do this type of analysis. And to simulate the traffic, you need to know, you need to have the simulation modeling techniques or models. So that models you can get from the traffic flow or traffic flow theory. Okay, so that is the purpose of traffic flow theory. So if I want to say like what are the different or key traffic flow concept used in disaster, the first one is the fundamental diagram that you might have actually studied when you did your bachelor's in civil engineering, where we have the one course transportation engineering, where we see the fundamental diagram. That is the speed flow density graph. This graphs actually helps you to see where is the free flow, then breakdown condition, which is critical in the disaster, right? We have also seen the shockwave analysis that will help you to predict the queue growth and dissipation or queue length, how long the queue length would be there, and that will help you to do that analysis. So basically, shockwave theory allows estimation of how fast congestion spread, which is essential for time of evacuation, okay, which is very important during the disaster. Then we have queue spillback models that will basically assess the risk of blocking the intersection and emergency access. Okay. So all this part of the traffic flow concepts only. This is also we have already seen. And how we will do that? We will use some macroscopic or mesoscopic model. So there are three types of model. One is microscopic, another is macroscopic, and third one is the mesoscopic. In disaster, particularly we focus on macroscopic and mesoscopic model because we are working at network level. If we work at particular road section, then only we will use micro models. Okay, but in the disaster, we are only majorly work with macroscopic and mesoscopic model. Until unless you have this microscopic or mesoscopic model, you cannot actually do the traffic or you cannot analyze the traffic scenario. So, which is very important in the case of disaster management. Okay. Okay. So next one is the discrete choice model for evacuation and route selection. So basically, this discrete choice model, what they do is they individually model the decision making under the risk and stress. As I said, you can model the mode choice or the route choice. Okay, so that is possible using the discrete choice models. And again, I'm not covering any mathematics, but they are really it comes from the econometrics, where economics as well as the theoretical human science is involved, and they come up with this utility maximization theory, and using the utility maximization theory they build these discrete choice models. Okay, so in disaster people do not always choose the shortest route, they choose what they perceive as the safest and most familiar. So this is the behavior in disaster, correct? So somehow you need to actually capture this behavior in your discrete choice model. So these models are calibrated in order to get this behavior and then do the route choice modeling. And as I said, discrete choice model help to represent this behavior in realistically rather than just assuming the perfect rationality. Okay, and these models particularly help to demand estimation. You need to know, let's say, if this is my city, and as I said, something happened here, then you need to estimate the demand. These discrete choice models will give you the demand from where to where people will travel. And this demand will go to the traffic simulation, okay, to do the evacuation planning. That's why the discrete choice models are very important. So basically, this discrete choice model captures the route choice during the evacuation, then mode choice, which mode people will choose, and the departure time decisions. So if you see, all are discrete. So when I say discrete, it's not continuous. So you have the limited number of choices, Okay, and which one you will choose, whether you will choose this, or this. And this can be do, and we will build the different discrete choice model for different, let's say for route choice, it will be different discrete choice model. For mode choice, it will be different, and departure time, it will be different choice model. And these discrete choice models account for first one, travel time uncertainty, second one, information availability, and risk perception and panic effect. So once you incorporate this one, then you can make the more realistic prediction. As I said, people will not choose shortest path, but the safest path. So that is the behavior we want to capture. Otherwise, the typical model will choose the shortest path, which is no of our use, correct? And we want to make some realistic prediction. In that case, this discrete choice model will help in order to get their perception about the risk and the panic effect. Okay, and we will make the realistic demand predictions. Then not all individual reacts the same way, correct? So basically, there are different categories. For example, elderly or tourist, or there could be some low income household, correct? So they behave differently. So all this behavior will can be captured using the descriptors models. So there are ways to do that, that I'm not covering, but what we can do, we can actually get the different behavior for different household or different people. Even male and female behavior will be different. That can be also captured and modeled differently and separately. So that is possible with the advanced discrete choice models. Then this behavioral model will allow planners to identify vulnerable population and tailor the evacuation plan strategy accordingly. Okay. And this links transportation modeling with social equity in disaster management. Unless we have like the proper behavioral analysis, then it cannot possible to get that, right? So social equity is very important. And once we use the advanced behavioral models or choice models, then it becomes easy to make the social equity when we do the disaster management. Okay. And as I said, there are some advanced behavioral choice models. These are There are like multinomial logic models and all. So if you want to go beyond the multinomial logic models, you can use mixed logic models, then latent variables. So the simple or traditional model is MNL in the choice models or discrete choice model. It is called multinomial logic model. Okay. And now there has been like advances in this traditional model, and new models are there. For example, mixed logic model or latent variable models, and that can be also used when we are using these discrete choice models. Okay. So it will predict the compliance with the evacuation order. Then it will evaluate the effectiveness of information dissemination and assess the vulnerability across different population groups. Population group means low income, medium income, or male, female. So there will be different population groups. So that can also be done using these advanced behavioral models. Okay, so the next model is the network optimization, right? So what we need to do is we need to also optimize our network when we are doing the disasters management. So basically, this network optimization model help to emergency routing and evacuation. And this network optimization identify feasible and robust path and not just the shortest one. So basically, the typical or traditional network optimization, they will always choose the shortest path and then assign the traffic. Okay, so if I want to go from here to here, it will give the shortest path and assign the traffic. But in the disaster, it has to be changed. Okay, so that's why we need to come up with feasible and robust path, and that can be done in the network optimization. So we need to revise those models. This is particularly helpful for ambulance routing, fire response, and guiding evacuated towards shelter. Okay, so that's why this network optimization is very important. So basically, it solves or it addresses the problem of damage or flooded link, reduced capacity, and dynamic travel time. So the model which we will build, that network optimization model, it will consider all these factors and then come up with the new algorithm and can be done the assignment, traffic assignment. Okay. And the key applications are simple. So basically, we will do the emergency vehicle routing, evacuation path optimization, and shelter accessibility assessment. That can be done using the network optimization. Okay. And the typical methods which are used, basically, these are the shortest path with constraint, because now the capacity is changed. There are some constraints. So this network optimization models will get revised with some constraint, and we will add one more component like time dependent component on the network models. So once we do that, then this new models becomes robust to do the routing and evacuation planning. Okay. So the last one, which is very important, is let's say now you have all the models. You have a discrete choice model, you have network optimization, you have everything. But now you want to test something, correct? So basically, you cannot actually, let's say this is my city, and you want to test some what if scenario. You cannot actually impose the disaster here and then test. You need some test bed where you can actually test your policy decision, and that could only possible in computers. So basically you need to do some simulations. Once you do some simulations, then those simulations will help to see what if scenario, correct? So with the analytical models, what happens, you can do some calculation by hand. Okay. But let's say you want to do some analysis at city level. So you cannot do that many calculations by hand, or there will be some interdependency in between the models. So that can only be done using the traffic simulation or simulation framework. So that we will be doing using, that will be using the simulation model. And one of the famous model is the agent-based model that captures the heterogeneous behavior, including this panic and non-compliance, and do the what if scenario analysis. And as I said, I have discussed already, there are different agent-based software. These are only few names, but there are multiple other softwares are available. Some of the are like free software, some of the are commercial, but that can be used to do this what if scenario analysis. Okay, so basically it will simulate the individual vehicle behavior and the pedestrian behavior, and it will also make the interaction between the different elements inside that particular simulation framework. And as I said, that will be interdependency between different system inside the framework. So that can be only captured using the simulation and cannot be captured directly using some analytical methods. And it will allow the different scenario testing. You can come up with the different scenarios, and this scenario will allow you to see your policy decision. Okay. So basically, you can integrate all these tools and come up with the transportation engineering tools. So we have seen the discrete choice model, traffic flow theory, network optimization, simulation model, and it will help you to evidence-based evacuation planning and residence transport. So these tools are required to do the integrated transportation engineering disaster management. So we majorly focused on discrete choice model, traffic flow theory, network optimization. And once it is there, then we discussed about the simulation models. Okay. So together it will allow you to evidence-based evacuation planning and resistance transport system that also we saw in the last slide. And this is very important. So always note that no single model is sufficient on its own. So there is no like one bullet solution for disaster management. You have different models and it will also change with different scenarios. It will also change with the type of disaster. But there are some frameworks which you can utilize and you can change according to the uh, your requirement and your policy decision. Okay. So you should always remember that no single model will solve your problem. You need to utilize the different models. Okay. And disaster management requires integrated modeling where behavioral, operational, and network perspective work together. Okay. It's not like it will individually work. You need to have the interconnection between behavioral, operation, and network perspective. Okay. So basically, this highlights the central role of transportation engineering in effective disaster management. And you should always remember that basically the major important factor is the human behavior in disaster because the transportation system fail not only due to infrastructure but due to the human decisions as well. So it's not only the fault of disaster, but human decisions are very important. And somehow we need to incorporate all these behaviors in your modeling framework. And this behavior, what we saw is panic driven route choice, herd behavior, non compliance with traffic rules, and risk perception. So, this is very important when you are doing modeling. It's not about machines are making decisions, but humans are making decisions, and the system fails because of human as well, and not because of the disaster itself. Okay, that you should always remember when you are doing the modeling for disaster. Okay. And as I said, what type of different data is required to do proper planning and modeling? The first one is GPS and mobile phone data that really helps to calibrate our model. Then traffic sensor and camera. Then social media and crowdsource reports that will also help to calibrate those models. And there are some emergency services. They also have some their logs, so that data will also helpful. For example, how many ambulance required, at what time ambulance left and all. So that will help to actually predict the behavior of the people as well as to model services that logs will be helpful. And of course, the remote sensing data is also important, which will include satellite and drone. And high quality imagery is important because you can do the real time modeling and actually real time control the traffic signals and everything. Okay. This is like you can say that the advancement, the smart and intelligent transport system. This could be one of the solution effectively model the disaster management. Basically, the role of ITS would be this is the new, or you can say advancement how we can do if we have real-time monitoring, adaptive signal control, emergency alert and routing, and decision support system. So here, if you see in this image, everything is connected to everyone. So this vehicle is also connected to this vehicle. This information is connected to this. Similarly, this information is going to here. This is already stored in cloud. So if we have this type of system, the ITS system, that will that will definitely help to manage the disaster in effective way. Okay, so that is the future of, you can say, disaster management. So that's why you can have AI-based incident detection. So you can detect the incident and act immediately. Then you can have a digital twin. That is also new topic to do the disaster scenario, where you have real world information or real world model of the system itself in the digital twin, and you can see the what if scenario. And the connected and autonomous vehicle, as I said, everything is connected to everyone. If you have that one, that will really help to effectively manage your disaster. Okay, so basically these are the some references. Again, it is not exhaustive list, but some references I put. But I would suggest you to read more on it. I have actually provided you most of the things, but you can read the different concept if you want to pursue or if you get interested. Okay. So with that, I will stop here, and I would happy to take any questions if you have. Okay, so yeah, I see some. Okay, so I will stop.
The session is open for the questions now. Are there any questions from the participants? Yes, and live feedbacks are also welcome. The participants can unmute themselves for the feedbacks.
Sangram.
Hello, sir.
Hello.
Yes,
Am
sir.
I
This was
audible?
Yes, yes, you are audible. Please go ahead.
I am
Yes,
teaching
Sangram,
on.
very good morning to you.
Yeah,
Actually,
good morning.
myself is, say, Dr. Anil Agarwal. I have worked in Karad Engineering College for some time, up to, say, 99, I was there. I
Okay,
think
okay,
you
great.
was studied there. Kumtekar was my head that time. And
Okay.
say, right now I am in Nikmar.
Oh, nice, nice, nice to meet you. Yeah.
Say, I have gone through your complete session one. Definitely, say, I do appreciate a lot of tools, techniques, or models. Say, you have, say, briefed in your very small sessions one, which is very difficult time one. And I think
Yeah.
whatever you have briefed, this, say, quantity techniques or say various say, models ones, it will be very helpful for the researchers, those who are doing PhD, and
Right.
not only in the disaster management, I think it can be applied to the various, say, application areas, which one can go ahead with that one.
Right, right, right. Yeah, so basically, again, I want to say that whatever I presented, I just gave the overview, and even
Yes,
if you just see the discrete choice model, so I teach one course, discrete choice model, where I only put one slide, but I teach 6 months course here.
of
So
course, yeah,
I tried to put everything so that if somebody wants to pursue their research, they can have an overview and they can go into depth, and they can also have a more what I would say
absolutely
uh,
correct. Yeah.
yeah, yeah. So don't take this presentation as like I have covered everything and all. So
No, no,
there
no.
are
Yes, yes, yes.
nuances.
Very, very good one for the those who can want what are the say tools, techniques which are available, what are the say simulation things are available, and
Right, right,
to their respective areas, say they can go in depth, say applying their knowledge one.
right, right, right.
Okay, that's all.
Yeah.
Thank you.
Thank you. Thank you so much, Dr. Anelia.
Yes, ma'am, now you can share your feedback as well.
Sorry.
Yes, sir. This is architect Shilpa from Pune, sir. Anantrao Pawar College of Architecture.
Yeah, please go ahead, ma'am.
We have this subject for as an elective, and we never know what to teach in this subject. So we got the overview, but how can you just put an insight how architects are responsible for this and how they can study and implement these things in the planning?
Yeah, so basically, as per my, do you have a master's course or bachelor course?
Only bachelor's course.
Okay, so in bachelor course, I'm not sure because this disaster management and all, it is two specialized courses. But what you can do is you might have a transportation planning course or maybe one module in transportation planning.
Yeah.
There you discussed it along with the four-stage travel demand model because what we do is first we teach four-stage travel demand model, and
Mhm.
after that you can have one more module where you will
Okay.
briefly talk about what are the measures can be taken when disaster happens. So as I showed, there are three phases. I showed three phases and what you can do in different three
Your
phases.
voice is.
Because hello, am I audible now?
Meanwhile, it went, but now it's
Okay.
audible.
Yeah. So basically, as I said, there are three phases. I showed the three phases when we particularly do the disaster management. So you can have a one module where you are discussing disaster management in terms of transportation planning because this comes under urban planning. If you see
Yeah.
the syllabus of urban planning, it is very important in the urban planning and how you can do the urban planning or transportation planning because urban planning and transportation planning goes in hand by hand. So there you can have a one single module, and if you have master's program then you can have a one course itself. So that way I can tell you you can incorporate.
Okay. And is any observation based like survey can we conduct that by monitoring the traffics in various chowks and all?
So yeah, there are multiple surveys. So traffic volume surveys are there, household surveys are there. But
Uh,
are you talking particularly from disaster management perspective or in general transportation perspective?
issue. Yeah, yeah. Any kind of issue if we see in the traffic,
Yeah.
that is
So
also noticeable.
yeah. So basically, you are from Pune, right?
Yeah, Pune.
Yeah, so basically recently they have done the CTS study for Pune. So they did
Okay.
most of the surveys and all. So you can just go to that report. It is I think available on Pune Metro website, and you will get to know what type of different surveys are required to first analyze the
Okay.
city. So same study you can follow and do the analysis.
Oh, yes. Okay. Okay. Okay, sir. Some students
Yeah,
are very much interested, so we can keep different kind of assignments. So this is also better.
yeah, you can
Wow, sir.
definitely you can do that. Yes,
Yeah. Thank you, sir.
yes,
Thank you.
yeah. Thank you, ma'am. Yeah.
Thank
Yeah. So, anything more from the side of participants?
Someone is asked about the Kumbh Mela. So for that, I would suggest there is one professor, Professor Ashish Verma from IISc Bangalore. He did some study on Kumbh Mela itself. I think Pradeep or someone asked one question on Kumbh Mela. So you can just refer to that. You will see how detailed work you can do when you are doing the disaster management for the event like Kumbh Mela. I hope I answered the Pradeep's doubt. I'm just going through the chat session. Yeah, any other questions? I'm happy to take.
Okay. So probably, if we get more questions, we'll collectively send it to you, sir.
Sure. No problem.
So I sincerely thank our today's esteemed resource person for an insightful session on transportation engineering and disaster management, with a strong emphasis on pre-disaster planning and preparedness as the most crucial part of this session. The discussion on emergency response and the post-disaster recovery has also provided valuable insights to our participants. The session has also highlighted how risk reduction strategies, vulnerability assessment, preparedness planning significantly uh, minimizes the losses of life, infrastructure, and economic disruption, while also addressing the challenge of unpredictable human behavior during the disaster. The importance of resilient building and transportation models, along with the data driven modeling frameworks, was also clearly emphasized and will certainly help all the research fellows who are the participants in this FDP. So, I thank all the participants for their active engagement and the organizing team for for a smooth conduct of the session. I request everyone to fill the feedback form, and our next session will begin at 2 p.m. sharp. Thank you. Thank you so much, sir. And thank you so much, sir,
Yeah,
for sparing your valuable time and guiding us. Thank you so much.
no problem, no problem. Yeah, thank you so much. Yeah.
Thank you.